The formal definition of NFA, non-deterministic finite automata, is similar to that of DFA. They both have set of states, an input alphabet, a transition function, an initial state, and set of accepting states. But they differ in one very essential way, and that is a transition function. The transition function of NFA takes a state and an input alphabet or an empty string and produces set of states, not only one state. The transition function of NFA takes a state, a symbol from input alphabet or an empty string and produces set of states. So here we have written power set of Q, that is actually the collection of all subsets of Q. So we can formally define NFA with the help of 5 tuples Q, sigma, delta, Q0 and F, where Q is a finite set of states, sigma is a finite non-empty set of input symbols, that is alphabet, delta, that is transition function, which we write as Q mapped with sigma including an empty string, results in power set of Q. Q0, which belongs to Q, is an initial state or start state. Fifth tuple F, which is a subset of Q, is a set of accepting states or final states. This is the formal definition of NFA. Now you must understand, when you write a formal definition of any NFA, you should also be able to write the formal description of any given NFA. And to write the formal description of any NFA, we have to use these 5 tuples Q, sigma, delta, Q0 and F. For example, if this is an NFA, how can we write the formal description of this NFA? We have to use these 5 tuples. First tuple is Q. So what is Q in this case? Set of states. So we say NFA N is equal to Q, sigma, delta, Q0 and F, where Q equal to set of states Q0, Q1, Q2 and Q3, Q0, Q1, Q2, Q3. Sigma is an input alphabet. There are 2 symbols 0 and 1. So we write 0, 1. Delta is a transition function. Delta is a transition function. We can write like this: Q mapped with sigma including empty string results in power set of Q. Now please remember, when we write formal description of any NFA, to formally describe the transition function, we have to write a transition table. So we can write transition table for this NFA. There are 4 states. So in the table what we have 4 states: Q0, Q1, Q2, Q3. There are 2 input symbols 0 and 1, but we also have to include empty string because NFA has capability to make a transition over an empty string. So Q0 on 0, the resulting state is Q0. So in this case there is only one resulting state, but please note that in NFA the resulting state is not always a single state. It is a set of states. Therefore, we write resulting states or state in curly bracket as a set. Next, Q0 on 1, the resulting state, Q0 on 1, the resulting state is Q0, Q0 on 1, Q0, Q0 on 1, Q0, Q0 on 1, again Q1. There are 2 resulting state Q0 and Q1, and therefore we write like this: set of states. Q0 on empty string, there is no transition, so we write a null set. Q1 on 0, the resulting state is Q2, Q1 on 1, Q1 on 1 there is no transition, so we write null set phi. Q1 on empty string, the resulting state is Q2. Q1 on empty string, the resulting state is Q2. Q2 on 0, there is no transition, so we write phi. Q2 on 1, the resulting state is Q3. Q2 on an empty string, there is no transition. Q3 on 0, Q3 on 1, the resulting state is Q3. Q3 on empty string, the resulting state is a null set. So this is the way we can write the transition table for a given NFA. Now next tuple is Q0. Q0, that is an initial state. So in this case, the initial state is Q0. Then F, which is actually the subset of Q, is a set of accepting state or accept state. So in this case, there is only one final state or accept states, but please remember it's a set of states. So we will write Q3 as a set having only one final state or accepting states. So when it is asked to write the formal description, we have to write in this way, and when we are formally defining the NFA, we have to use these 5 tuples Q sigma delta Q0 and F